Hey there, welcome to my channel. Today we are diving into function calling in AWS Bedrock. That's service from AWS that helps you to build and scale generative AI applications. And if you're curious how to invoke custom logic in your generative AI workflows, or you're just new to the cloud and want to learn something cool, then this video is for you. Before we jump to the code, let's do a quick recap of AWS Bedrock. AWS Bedrock is a fully managed service that gives you an access to foundation models from different providers such as Cloud, Llama, and Amazon's own Titan models. It means that you can easily build, customize and deploy your generative AI applications without having to deal with headaches like server provisioning or model hosting. And if you are already familiar with AWS Cloud, then it can be a natural extension of your knowledge, just with AI twist. What is so cool about function calling? Sometimes you may want to use your model for something more than just to generate text. For example, you may want to trigger the piece of code that fetches some real-time data, the weather, currency exchange, or maybe the latest news headlines. Or maybe even to orchestrate some logic in your backend. Basically, you want your AI model to say, hey, let's call this function and do something with that data. This is incredibly powerful when you're building chatbots or interactive AI applications. Instead of relying on model to guess everything purely from the text, you can supply it with a function that performs some special action and retrieves fresh data. And it bridges the gap between generative AI model response and real-world up-to-date functionality. So what is our plan for today? In this video, I'm going to show you two ways of function calling in AWS Bedrock. And the first way, the easier one, will involve almost no coding. We only need to provide a code for our custom function that we are going to call. And everything else we are going to do in the UI of AWS Console. And the second way will be a bit more involving. We are going not just to write the code for our custom function, but also we are going to implement function calling using the Converse API in AWS Bedrock. And even though the first way of doing it is easier, the second way will help you to understand how the function calling is actually working under the hood. So if you're ready, let's get started. By the way, if you're not familiar with AWS Bedrock and don't know how to set it up, then check out this playlist where I'm showing how to set up AWS Bedrock and start working with it. Okay, so let's start with our AWS Console example. Here we have to go to Amazon Bedrock and you have to make sure that you have your foundation models enabled. So if you go to the model catalog, you can see which models you have and if access is granted for some of them. And if you don't have any models enabled, then you have to go and enable them. Just go to the page of the model and then click here, available to request model access, and then you can modify model access and choose any model you want to work with. But if you want to know more details about it, then check the video about setting up Amazon Bedrock. I already recorded it in this playlist, so don't hesitate to check it. Okay, so everything is enabled in my AWS Console, so I'm going to just go to the agents here under the Builder Tools section, and here we will create a new agent. Let's call it our exchange agent, because we are going to check currency exchange rates in real time. And here description is optional. It's just for you to know what this agent is doing, so you can skip it. And let's hit create button. Okay, so here we are in the agent builder interface. And here we need to create an action group for our agent. And action group is basically the way to tell which function we want to call. And we will call it again get exchange rates. And again, description is an optional here. And we can define it with function details or API schemas, and I'm going to go with the first option, and we are going to create a new Lambda function. You can also select an existing Lambda function if you already have it in your AWS, or there is also a return control option where agent will prompt the user and ask for function details to generate a response. But we will go with the first option and we will create a new Lambda function. And let's call it exchange rate, and description, again, it's optional, it's up to you if you need to add it, if you want to add it. And then the important thing here, we need to define parameters for our function that we're going to call. For currency exchange, we need to know two things. We need to know the base currency and we need to know the target currency to get the exchange rate for these two currencies. So the base currency is going to be base currency name, and then we are going to add a target currency, and then it's going to be a target currency name. So here the description is not optional. You need to explain what this parameter means to help model to understand when and what it should put here. So don't forget to add this description or your function calling might not work very well. Okay, so now we are hitting create here and it will create our agent. Okay, our agent is created, and now let's go to our action group and let's go to our Lambda function. You can click here on this view button and it will open the page for your Lambda function, and here there will be some boilerplate code that just returns a string. That function was called successfully, and we will make changes in this code. In this case, the code is in Python, but you can change it. You can write code in any language that is supported by AWS Lambda service. We will keep it in Python, and I already wrote a code. And I'm just going to copy paste it, not to waste the time. So what our function will do, it will call the API, this API, it will call it and get the rates for the base currency, and then it will choose the target currency from these rates and return it to the user or to the model, so the model can generate a proper response. Okay, first let's import the library that is going to help us to make API request. It's going to be this URL lib3 library, and it is supported by AWS Lambda out of the box. And then we are going to get our base currency from these parameters here. This is a code. I'm not the best Python coder, so this is probably not the optimal way to get the parameter, but okay, let's leave it as it is. So this will get base currency from these parameters, and then we need to do the same for a target currency as well. So we know both of these, and then we are going to call our API. So we need to create this HTTP and then to generate a link for the API. And you see here we are passing only the base currency, and then to make a request and save it into the response variable. And then let's parse our response. We are going to get the actual value for the target currency from this response. And then here where we are sending this response body, this is the boilerplate one, we can just replace it with the target rate. And we can delete this one. This is our minimalistic Lambda function that we're going to call. So let's now deploy it, and it's deployed. So now we can go back to our agent, and here let's go to the agent builder main page. So here we have this save button. Let's click it. And then there is another button, prepare, and it will update this little test agent to use our latest changes. And now let's first say hello and see if it will. Agent instructions. Okay, we need to add this agent instructions as well. I forgot about it. And it should have a minimum of 40 characters. So let's add it. Let's say that's probably not the best description, not the best instruction, but it will do the job, I think. And again, we are saving and preparing the test agent, and let's try again. Let's say hi. And it even says, welcome to the currency exchange rate service. I'm here to help you. Okay, give me a rate for dollar to Japanese yen. Yeah, I made a typo. Okay, my request rate is too high, so I have to wait a little bit, or maybe I could try to change the model. For example, to this one. Maybe it will let me to make requests. And again, I'm going to save, and I'm going to prepare, and again we'll go hi. Okay, it gives me a strange monologue here, but that's fine. Let's ask about the exchange rate, and it encountered the error processing the Lambda response. So let's go to our Lambda. Maybe let's go to our Lambda and make some debugging. Maybe I forgot something here. We can go to monitor, and we can see CloudWatch logs to see what Lambda returned. Maybe what we can do is to change the response a little bit. And here in our Lambda, let's go to the code, and let's, I deleted some code, but now I'm wondering if it would be better to return it in the format like it was before. So let's just change it a little bit. I'm going to place it here, and I'm going to just replace the body here, and yeah, I'll do this. I'll try to keep the shape as it was in the dummy Lambda, and I will deploy it. So now let's go and try our agent again. Go back here, save it, prepare it, and let's ask it about the rate, dollar to Japanese yen. And now it works, and it returns us current exchange rate that is not looking very nice, to be honest, but we could format the response in our Lambda function, let's say to round it to a certain number. And what else can we try? We can try how much will be $123 in Japanese yen. Will it be able to calculate it? Oh yeah, it even calculated it, and hopefully it does it correctly. Let me check. So I'll bring up the calculator. So 123 multiplied by this crazy number is equal to 90,251. So this one is not very correct, it seems, but what we can do, we can implement another function, and that would be, let's say, a multiplier function, and tell it to get data from this from this response where it asks about $123 in Japanese yen and get the current rate and multiply them, because you know large language models, they are really bad at math. They're almost as bad as I am. If you want them to do math, you better use another custom function for that. But in general, that's how it works in AWS Console, and you can see it was extremely easy. Even though we had to do some debugging and fix the function, it took me like 10 minutes to create this agent. So we tested our agent here in AWS Console, and the last bit of work that left is to call it from our chatbot application. And in order to do so, first we need to create alias, and I already created one here. So I called it Exchange Agent, and it granted it some alias ID. But if you didn't do that, you need just to hit this button and choose some alias name and hit Create Alias button. You will need it to be able to connect to this agent through the AWS Bedrock library for client. And let's go to our code. So this is a branch from the last video, from the knowledge base video, where I already used this package, client Bedrock agent runtime, and I'm using it here to call this retrieve and generate stream command to request data from our knowledge base. But to use the agent, we need to use a different command. So this command is invoke agent command, and here is the documentation for it. I will leave the link below the video in the description if you want to check it out. So invoke agent command, what does it do? This command calls not just the model, it calls the agent that we just created, and you can see that there is a lot of parameters you can pass. We are not going to pass so many of them, we are just going to pass the required ones. Let's start here. Some things we can leave unchanged. So here we are creating the Bedrock runtime client, we can leave it as it is. And then here we are replacing this command. Instead of retrieve and generate stream command, we are going to use invoke agent command. And you see it highlighted this property because the input for this command is different from the retrieve and generate command, and we need to change it slightly. We don't need this bit because we're not retrieving anything from the knowledge base, and this one is going to change. It's going to be input text, I think. And it is still red because we are missing few required properties. It's agent ID, agent alias ID, and session ID. So let's paste it here, and we can get these values for these properties from our agent here. So agent ID is this one, obviously, and we can just paste it. And agent alias ID, we just created an alias, and we can scroll down and find the alias ID here, and session ID. So that should be some unique ID, just a string. And for this example, I'm going just to do some random string. This is just to know when you're doing a request, to know which conversation this request belongs to, so the agent knows the context, kind of. That's all we need. And here the input text contains our prompt. We can try, I guess, to call it. So let's save it and let's go to our chat interface. We can just send something first, and you can see that something happened here, and there was a response returned. There is a stream response, but it is blank here. So what do we need to do here? We need to change this parse response command, because if you look at the documentation, the output of this command will be slightly different as well. So instead of the stream that we have here, it would be a completion. Yeah, and we can just, we can change the type here, so it will be easier for us. It will give us the hints what we need to change. So here we need completion instead of the stream. Here again completion. And instead of the item output, that would be a chunk, I think. Yes, and here as well, chunk. And the one last thing we also need to do, we need to decode this chunk. And here to pass the decoded value in here. And this should fix our chatbot interface. So let's try again. Okay, so it says that it can assist us by providing a currency exchange rates. Okay, let's ask what is the exchange rate for Bulgarian leva to British pound. And it returned as the answer that the current exchange rate for Bulgarian leva is 1 BGN is equal to 0.43 British pounds. That sounds about right. And that's it. We connected our AWS agent to our chatbot application in almost no time. So that was it for the first implementation, for the easy one. And now let's move on to something different. And now we are going to try to implement our function calling using the Converse API in AWS Bedrock. So to start with our Converse API implementation, we will switch back to the branch 0.5 multi-model from one of my previous videos where we implemented a multi-model chatbot with Converse API. If you want, you can check it out here. Yeah, I've switched to this branch because here I already use the correct library, correct package client Bedrock runtime. And I'm calling here this Converse stream command that we are going to use, but actually we are not going to use a stream command. We will switch to the normal one that returns the whole answer at once, because it's just going to be easier for us during the development. But if you want to do it with stream command, it is also possible, just a little bit more tricky when parsing the response. Okay, so let's just start. First of all, I want to share a couple of pages of documentation for this that I will use. The first one is this guide, Intro to Tool Use with the Amazon Bedrock Converse API, and this has some code in Python, but even though we are going to use TypeScript, this is almost the same. I mean, the logic, the API contract, they are all the same. The only difference that you will write it in TypeScript. I mean, I will write it in TypeScript, but you feel free to use the Python code if you prefer. And another useful bit of the documentation is, and this is the user guide, how to call a tool with the Converse API. And it has these examples. They are language agnostic. This is just what you need to pass. The order of the calls to the model. So first we are passing the list of tools. List of tools is the list of functions that we can call, and we add the name and the description for the function so model can understand what is this function for. And we also add the schema with the properties, parameters we need to pass. For example, this function in this example requires one parameter to pass, and this is the required parameter sign. And then after we defined our tools, we can send the prompt to the model, and if model identifies in this prompt that it needs to call a function to get the relevant information, then it will return us an answer, a response, and it will say that it wants to use this tool, and it will pass the name of the function, the input, and the tool use ID. The tool use ID is an important bit for us and for model to understand to which particular message it is relates to. And we need, when we get this kind of response from the model, we need to call this function ourselves, get the data and pass it back to the model. And after we do this, we can pass it as a tool result to the model, and model will understand and generate a proper response using this data that we just got from our function. And if there is any error, or if the function returned like not found or something, we can also handle this case and pass that we couldn't find the requested information, and model will handle it as well. So this is the general logic of our today's implementation, and this is a very useful piece of documentation. Of course, I will leave the link below the video as well, so you can go and check it out. But now let's just start. And the first thing we are going to do is to define our custom functions. We can do it in a separate file or just here in the top of our app.tsx. I will do it just here, and I already prepared the code for these functions that we are going to use. And here it is. This is two functions. One is for sum of two numbers. As we already could see, the models are not very good with math, so this function just does the basic math for the model. And the second one is just the same as in the previous example. We are fetching the currency exchange rate and give it to the model. So here we have a little bit of TypeScript unhappy. I will just ignore it for now. And yeah, this is the definition of our functions that we're gonna call. And the next, we need to describe the schema of these functions to our model. And I'm going to make it in a separate file because it is quite a long one. And again, I'm not going to type it all just now because I prepared it already, and I'm just going to copy paste it. Here is the definition of our custom functions, and it is absolutely the same as here as in this example. So I just copied this and I changed the name of the function and parameters. Okay, so the first function has the name sum of two numbers, and it matches what we have here. And then it has the input schema, JSON object, properties X and Y, both are numbers, and I'm explaining to the model that this is just the first number to add and this is the second one, and they both are required. And the second function is the get currency rates one. Again, the name should match what we have here. And this is another input schema where we tell that we have one property, base currency, and this is required property as well. So these are the necessary preparation for our function calling. And now let's just try to tell our model about these functions that we have. So how do we do that? We have to go to the place in the code where we are calling our model, and this is here in the send response. In the send response function, we have this API response call that uses Converse stream command, and I'm just going to change the Converse stream command to just Converse command. I don't want stream right now, and everything else here will stay the same for now. And what I'm going to add here, I'm going to add a tool config. Again, I'm following the documentation, so this tool config will contain the tools, and these tools are from our tool schema. So I'm just importing it here. And now when we are making a request to our model, we are passing this information so model knows what to do. And now let's just try it out and see how does it look in the network calls and in the UI. So as before, I'll just try to ask something. Oh, and of course I need to handle this differently because I removed the stream. Yes, I need to change this function, this parse response as well a little bit. So I'm just going to remove this bit for stream. So I'm going to comment this out and implement a different simple logic that will check for message. And yeah, I also need to change this. So now this message is what our model returns. And what we can do, we can just, so here we have this add to history command, but I don't really want to pass it as a text. I want to pass it as a message. So for now, I'm going to use just the set history, and I will pass this message here. It is not happy about something. I think it's because we have a different message here, different interface. Let me just refactor it a little bit. So here it's going to be message from this Bedrock client runtime, and it will make our TypeScript go a bit wild in different places. So I have to fix it a little bit, and it's not happy about the undefined here. So let's just add the condition that message is not undefined, and it's happy now. So other stuff we have here is this add to history, parsed response. I actually don't think we need to add to history now because we're adding it in the parse response anyway. So here we can just call it. And here where we display, it is not happy because content is possibly undefined. The role is not assignable to type string because it is also could be undefined. And here again doing this, and it's again not happy with the fact that it can be undefined. But okay, this is a bit hacky, but it will do for now. Yeah, let's just test it right now if it's going to show us the messages. Yeah, and we can see here the output, and you can see that we have a tool use here, and in addition to the normal prompt. So if I just say, for example, if I just say hi, it does not return us a tool use because it cannot detect any need for a function, for a custom function to call. But if I ask it, how much is 5 plus 9? And then I'm going to check it here. You can see that it has not just the text response, but also the tool use, and it provides us an input of two variables, and the name of the function and tool use ID. So now in our code, we can take this stuff and we can call the function, and then to give the results of the function back to the model. So let's just do it. So I'm going to delete this one for now. And here in our parse response, where we are checking for the message, we can check for something else. For example, here, when we get the tool use, we get also a stop reason tool use. So we are going to check if the stop reason is tool use and call our tool in this case. So let's add another condition. If message and API response stop reason is equal, and it even gives us options, so you can select tool use. And then in this case, actually, you know what, let's first make it negative. Let's say we want to know if this is not equal a tool use, and then we just set it to the history and show to the user. But then if message and this one is equal tool use, so when it actually wants us to use a tool, then we need to find the name of our tool. So just let's assign it to the constant first, and then let's see where it lives here. Ignore this error for now, it's okay. So we need to find one of these objects here in the content array that has a tool use, and let's just do it. API response output message, and then content. In the content we can find, because content is an array, but we can find a block that has a tool use property, and here it is our tool use, and we actually want to return a tool use from here. Yeah, so here we assigned this piece of data, so we can use it to make a call to our function. So now another if condition, if tool use, if you found it, then we can get the function name and call the function. So this would be tool result, and you know we have our tools over here defined already. So let's say we want to call this function get currency rates. It should be an asynchronous call. So I am going to do the following. I'm going to do await tools, then I'm passing the tool use name, and again is not happy. I will just do this for now, and to this function we are passing tool use input, and this should give us our tool result. So we can just console log for now, and we can go and check it once again, and you can see here our total result is 14, and we are only getting it here. We're not getting the answer in the UI yet, because we need to pass it back to model, and that's what we're gonna do next. And in order to do this, we need to send response again, and we already have our send response function, but what I don't like about this, it is tied to the prompt and file here, and what we basically need to pass is just these messages. I'm going to do some refactoring just to make it easier to reuse this function. Instead of this stuff, I'm just going to pass the messages, and it's going to be an array of messages from user and model. Then I'm passing it just here, and this bit I will remove from the function, from the send response function, and it will live now in this onSubmit function. So here we created our content, and here I'm going to change this as well. I don't want to use the add history, I want just to use set history state, and I will directly set it here, and I will set previous, and I will set the content here with the role user. So this is our initial prompt, and instead of sending this prompt and file here separately, we are just going to send the entire history here. But because of how React is working, the update of the history state that we've done here will actually happen later in the code after this function is done. So here we are actually going to get an empty array or like outdated history. So I want also to change the way how our code is working in terms of like the looking, instead of like the sending the response here, I'm just going to subscribe on the all updates for history and send the response every time when history is updated. I mean, when it's updated by user, not for the model. So here I'm going just to comment this out, and I'm going to add a use effect. Let's say I'm going to use it here, use effect, and our use effect is going to depend on the history. And let's import it. We are going to get the last message that is going to be a fresh user prompt, history length -1, and then we're going to call our model, and here we are actually going to do this. We're going to send the history, and in this case it's going to be messages, sorry, yeah, and we are going to parse the response. So we define this function, we are not calling it yet, as you see, and here we are going to add a condition. If our last message role is equal to conversational role user, this is coming from Bedrock library again, and here in case if the prompt belongs to user, are going to call our model with our history. So every time when we add a message to history, we are going to call our model in case if this message belongs to user, because if we are getting a message from the model, we don't need to call the model again. Obviously we can delete this, and we can try to test it first to see if it's working, and for now it is complaining on something. Last message role, okay, it complains because we need to go to the use effect and probably do something like that. Not sure why my VS Code didn't tell me. Okay, so let's try. We add the message, and in the network tab you can see that we sent a request, so everything seems working fine for now. So we refactor this piece. I think we can delete this one probably. Yeah, so let's get back to our parse response function. So we stopped here. We stopped here on the getting tar result. I'm going to create a new variable. It's going to be temporary history, because now we need to send this data to our model, but we don't want to put it in the main history object yet. We first want to get this prompt and get this result. So let's create this temp history, and it is going to equal a history for now. And then we are going to go to this condition and add some stuff to this temporary history. So first of all, I want to add this message that we are getting here to our history. So let me do that. It's gonna be an API response, output, message, I think, and it thinks that it could be undefined. Let's just add a check here. So now it's not complaining anymore, and we can get rid of question marks. So we added it to our temporary history here. And then the second thing we need to do, we need to add the result of our tool use to our temporary history too. So once again, we are doing this temp history push, and here we are creating a message role, conversational role user, and the content is going to be it's going to be an array first of all, and then this content will match this tool result shape. So we need to push our tool result. You can see it needs to know the tool use ID. And now let's just copy it. Tool use ID. Where do we get it from? We get it from our tool use object. And it's here. Then the second part is content. And the content is very simple. It's just JSON. In our case, it could be also the text or something else. So you can see it here. Top result content block. So different options: JSON, text, image, document, or unknown. And in our case, it's going to be JSON. And I'll just do results. And here tool result. And it's not happy about something. Oh yeah, it's because here I need to wrap it up in another brackets, curly brackets. Yeah, so here we are passing tool ID and we are passing our result. We are saving in the temporary history. And now we can do again what we are doing here. Where was that? Yeah, here. And you can see it's complaining that it needs parse response here, but we will fix later. So we need to call our model and we need to call these two lines of code in here where we are getting our temp history. Yeah, so why don't we want to push it into the normal history? Because we don't want to show these technical messages to the user, because they're kind of intermediate messages and we don't want user to know about it. We want to show only the final result of this, and the final result of this will be triggered here in our parse response. So now let's just test it. I'm pretty sure I forgot something, but anyway, 5 plus 6 and yeah, you can see that tool result is 11, and here in the network you can see we did first request to the Converse. Let me zoom in a little bit. I'm sorry, I forgot to do it earlier. So that's the first request, Converse, and it responded us with the tool use, and then we made a second request, and in this request we passed our payload, we passed our messages, the question, the initial question, the tool use, and the tool result, and we got the final message, beautiful, for the user that we can show to the user actually. Yeah, so that's how it works. We tested our sum function, but we did not test the other one, the get currency rates. So let's ask for this as well. And let's ask, let's say, what's the exchange rate for Bulgarian leva to dollar? And again, first request, then you can see that this time we are making another request to the external API here between these two calls, and then we return the data and it gives us this beautifully formatted response. And if you noticed, we only pass here the BGN, and I don't even tell to the model here in these messages, I don't even tell it in the tool result that I want to get BGN to dollar. Just return the whole thing, the whole response, and then the model itself understands that the dollar, it must be USD, and it picks it and it shows that us here, and it even rounds it to the 4 digits after the point. So that works very nicely, and if you ask me, I personally prefer this implementation with the code that I've done myself. It seems a bit nicer to me than all this AWS Console stuff, because this is a code purely controlled by you. You can change everything. Just as a last thing, we don't need some of the stuff here. For example, we don't need this stream. Let's just get rid of it. Let's just make our code a bit nicer. We don't need this. And another thing that TypeScript was complaining about, that we need, IDE was complaining, not TypeScript, that we need to put the parse response here as a dependency, and then we need to put parse response into use callback and add some dependencies. I think it's gonna depend on our history. Yeah. And let's import the use callback. I think now our TypeScript is not complaining, our IDE not complaining on anything. So again, we can test it. So it says us about the get currency rates, and let's test our currency rates again. What's the exchange rate for Japanese yen to BGN? And yeah, this is the nice and beautiful response. So this is our function calling implemented here in the React chatbot application, just with the TypeScript and with the AWS Bedrock API. And that's it for today. And here it is, our mini crash course on function calling in AWS Bedrock, even with a TypeScript demo. Of course, in a real-world scenario, you would have some additional checks, error handling, and security measures in place. But this video demonstrates the core idea. You provide the function and its schema to the model. You let the model decide when to call it, and then the model uses the data returned from that function to provide an accurate response. And if you find this video useful or have any questions about AWS or coding in general, drop the comment below the video. And don't forget to hit that like button and subscribe for more AI tutorials. Thank you so much for watching, and see you in the next video.